In this video, I want to give you a complete buyer's guide to lasers, specifically lasers like these, which are really great for metal fiber lasers. All right, let's jump into it. All right, so how this video is going to flow, we're going to zoom way out and talk about lasers in general and kind of how fibers fit into that, what they're really good for, and then get further and further into giving you specific machine recommendations that I think could be really good for you. And if you want to skip all of that stuff at the beginning, there are timestamps down below. You can also check out my website, machinesformakers.com, where you can see my top picks as well as all the other machines that are out there that you may want to get. But first, why fiber lasers? And there's really two big reasons. The first is going to be about the speed of the machine itself. And this actually isn't just limited to fiber machines. You could actually get like a CO2 laser tube into something like this, as well as a UV laser tube. But in general, when you're talking about fiber, you're talking about something that either looks like this, or this box is like split over to the side and you're still in a form factor like this. Because the movement of these machines don't happen on a big gantry, which is what you're gonna find with a desktop CO2 machine, or like the xTool S1, which I have right behind me, which physically moves a mirror and lens around the work area. So you really are limited by physics in terms of like the top speed that you can get. With this, the movement happens right inside of here. This is actually a galvanometer, which is just like a little mirror that reflects all around. And that is how you can get super, super high speeds. And as a means of comparison, a like really good speed on a CO2 machine is like 1,000 to 1,200 millimeters per second, where with these, a low end speed is going to be like 4,000 millimeters per second, with a lot of these pushing 10,000 millimeters per second. So if you're needing to do things quickly, these could be a good option. And hopefully you can kind of already tell the limiting factor is going to be the size. Where those big gantry style machines, you really are only limited in the machine itself. And where with this, you're kind of limited by the optics, like how far can you reflect that beam and still have it in focus, since it's all getting generated at one spot. Kind of the max typically with these is about 300 by 300 millimeters, which is just shy of like a foot by a foot, but you'll see a lot of them more in like the 150 by 150 millimeter range. But really the second big reason, and probably why you have been directed towards these style of machines, is the fact they are excellent at marking on metal. And not just like anodized metal, meaning there's like a coating on top of the metal and that's what you remove, but you can definitely do that with a CO2 machine or even like a diode machine. But this one you can do raw metal, and all of it has to do with the actual wavelength of the laser itself, because different wavelengths will interact with materials in different ways. Actually, right here is a chart I've used in the past that has a bunch of different wavelengths of light, and right here in the middle where all the colors are the visible spectrum of light. And that is why with our diode lasers, so like the xTool S1, the Creality Falcon, the We Create Vision, you'll have like a purplish blue light because you have a wavelength of light for those lasers that is in the visible spectrum. And then you've got UV on one side and then infrared on the other. Infrared is actually where we're going to find our fiber laser. It's got a wavelength of 1,090 nanometers, and then all the way on the other end of infrared is our CO2 machines at over 10,000 nanometers. And what that means to you is wavelengths around that 1090 nanometer range interact really well with metal. Now, in terms of how these actually work, these are utilizing a solid state gain medium that is opposed to a gas gain medium. So on like a CO2 machine, CO2 is literally carbon dioxide, which is gas. That's what you have inside of that glass tube. Then you're pumping an energy source through that gas, and that gives you your photons, which gets focused down into your final laser beam. So with this one, it is solid state. And that's actually kind of where the name comes from, because you're using a fiber optic tube. So that is what this guy is. So inside of this tube, you have rare earth metals that when energy is pumped through it, that is what is giving off your photons, bounce around through the galvanometer, get focused with your lens, and then go to wherever you need on your workbed. One thing with these, just like with bigger lasers, your lens is actually removable. So a lot of times when you see these machines, you may see multiple like work beds listed out. That's because you can buy different f-theta lenses. So this is a lens, just like a camera lens. In this case, this one is for 200 by 200 millimeters, but you can also get ones that are wider as well as ones that are smaller. Coming back to the materials, again, fiber is going to be excellent for metals. You can also use them with like hard plastics and rubber, but like organic materials like wood and leather aren't really going to be the best use case for a fiber machine. They can mark on it, but that wavelength really isn't set up for it. Definitely go with like a CO2 machine or like a traditional diode style machine. Those will give you a lot better results. And here's actually a big chart of the different style of machines and the different things that they can mark on. And to make things a little bit more confusing, one column on that chart is actually a subcategory of fiber, and that is MOPA, which stands for Master Oscillator Power Amplifier. And that is a different way to amplify the beam. In the case of like a traditional fiber machine, you might see them referred to as Q-switched. That's kind of how they're amplifying the machine, versus the MOPA is using that oscillator. And what that really means for you is it's going to open up a whole nother category of settings inside of your software, specifically the pulse width. And just like with frequency, being able to modify your pulse width is also going to give you different effects on the material. And really kind of the most common ones are the colored markings that you'll see some people do on stainless steel. I don't think these are as big of a deal as I think the marketing likes to show, because it's like super dependent on the angle that you're looking at. So the results definitely vary depending on where you're standing, but they're pretty common for doing like black markings on aluminum. So, and MOPA will also give you like a wider range of frequency. So you've got like 40 to 60 hertz on a traditional fiber versus 20 to like 4,000 hertz on a MOPA. And then the pulse width is constant on a traditional fiber machine versus you have a range with the MOPA. And MOPA is more expensive, a lot of times a good bit more expensive. Unless you have like a specific use case that you know you need a MOPA machine for, I would stick with the traditional fiber until hopefully those MOPA prices come down and more in line, and then maybe that will make more sense in the future. Okay, so that's like the overall technology. Let's drill a little bit more into the machines themselves, starting with power. So like the most common question that I see is like, how much power do I need? Because price definitely scales with power. And you really aren't gonna find a fiber machine for less than 10 watts. And honestly, if you do, don't get it because more than likely it's not actually a fiber machine. It's a traditional diode that they're marketing as a fiber, and you don't wanna get it from a company that's doing that. So kind of the starting end of a proper machine is gonna be 20 watts. It's actually what the F1 Ultra is. It's a 20 watt traditional fiber machine. This guy is actually 60 watts from Monport. This is a MOPA machine. This is a machine from G-Wick. This is actually their Max, which I believe is actually pretty high in wattage at like 50 watts. Kind of the range is going to be 20 to about 100 watts, because what we're talking about is just engraving. If you want to get into metal cutting with a fiber machine, this is not going to be the video for you. That opens you up to an entirely different class of machine, an entirely different class of price as well. And actually, this is a really good chart for required power, depending on the different things that you want to do. You can see basically all of these are in the 10 to 50 watt range. And where the additional wattage really gets you is increases in speed. So while machines might be advertised to run at 10,000 millimeters per second, you probably won't practically be able to do that with lower wattages, just because it doesn't have enough power to keep up with the speed. Also, if you're doing deep engravings, whether it's just like a single engrave that you're wanting to etch deep into a piece of metal, or like the 2.5D relief engravings, those take a long time, like several hours, because you're basically doing like hundreds of passes to be able to carve away whatever that design is going to be. So the faster that you can go at the higher speed, it's going to be what you need. And then to go along with that power is the manufacturer, not like Monport or G-Wick or Cloudray or CommMarker or LaserPecker, all the different companies that are out there, but actually the manufacturer of the laser source itself. And you basically have three. You've got Max, Raycus, and JPT. I would steer away from Max, and a lot of times if they don't advertise what the source is, it is going to be Max, and that just isn't the best quality. Try to avoid that if you can. Raycus is pretty good. They make good machines, but then at the top end is going to be JPT. And a lot of times, if it's a MOPA machine, they're gonna be using a JPT source. So if you see Raycus or JPT, you should be good to go. You've got a good laser source inside of your machine. But then the biggest visual difference that you're gonna see with these machines is they kind of come in two different form factors. And I have like a miniature version of that form factor right here. Actually, the G-Wick machine is a little bit of a standout. This they call the split design because like your power and then your actual galvanometer and where you pin everything down into is going to be split into two different pieces. This was basically like the only type design we saw a couple years ago, but then a very popular design we've been seeing a lot. It's kind of these like all-in-ones where basically they took your power source, flipped it down, and then put this on top of it, which is more or less what they're doing. And I wouldn't say like one's better than the other. The split is a more traditional design. So you might find the more like industrial manufacturers are gonna give you something like that. You typically can have a little bit bigger work area, and a lot of times they're gonna have more power versus something that is shaped like this. But honestly, these have come a long way just in the last few years, where this is a 60-watt MOPA, and actually like the base is very, very thick. I've got a couple from EM Smart that are a little bit more slim. We already talked about work area, and again, the lens is going to be the key factor with that, but it can't get any bigger than the actual work area itself. The work bed, and typically the work beds will be something like this, where they're gonna have holes for threaded inserts. That's where you can drop in your jig for positioning, so you can be able to do repeat cuts over and over again. And then in terms of focus, basically all of them do it the same way. You're gonna have actually 2 red laser dots that are gonna get focused down together, and wherever those dots overlap, that's when you're gonna be in focus. Sometimes that laser dot is gonna be internal to the laser head itself. A lot of times, like with this one, they might be external. And then really like the only differentiator is some machines, this will be a lift that is powered, so you have like a button to drive this up and down. And then a lot of other ones will just have like a lever on the top that you can just spin up and down to drop this up and down. I wouldn't get a machine just because it has an electronic lift, because honestly, to manually go up and down is not hard whatsoever. Now, a few machines actually have autofocus, like true autofocus, where it can detect the thickness of your material. The xTool F1 is kind of in its own class because it's got integrated cameras. They're also using their same like laser sensing technology that they have in their xTool P2 to figure out the thickness of your material, but you can also manually focus it as well. And in terms of interacting with the machine, most of them are gonna be pretty limited versus like the touchpads and control panels you have on bigger desktop machines, on bigger like CO2 machines, and even like the desktop diode machines. You're usually just gonna have like a few buttons for start, stop, and pause. And then a lot of them will have like an emergency switch that will cut off power completely. Again, the F1 Ultra is a bit of an outlier. It has a touchscreen screen on it, and a couple other ones do as well, but that's not really gonna be standard or something you absolutely have to have with your machine. And then for software, the majority of these are gonna work with Lightburn as well as EasyCAD. I always gear people towards Lightburn because you can do all of your other machines on there as well. They've done a really good job bringing Galvo support into their software, and it continues to grow. And again, the xTool F1 is going to be an outlier where they're using their own xTool creative space, and we'll talk more about the xTool F1 here when we talk about recommendations. And speaking of recommendations, let's talk about some of the machines I think that could be a good option. So I'm over at machinesformakers.com. This is my site where I basically try to put all the information I know about these machines into one spot so you can kind of compare and contrast them, as well as giving you some of my top picks on the ones that I like. So the way we're gonna do this is we're gonna talk about both the Pro Galvo and the desktop Galvo. And again, the Pro Galvo, those are gonna be those like split style design, like a big version of what this is. And then our desktops are going to be more of this style design. And then within that, we're gonna talk about fiber, and we're gonna talk about MOPA individually. So fiber and MOPA over here on the left. So we're gonna have like a 4-quadrant deal, and I'm gonna give you some recommendations within each one. All right, so let's start off at the cheapest. We're gonna go a desktop Galvo, and we're gonna do fiber, so not a MOPA machine. And then I'm gonna sort this by price from low to high. And you can see right here is more or less what I kind of recommend. What you're gonna find with the majority of these machines, once you set on a form factor, so a desktop integrated design or a split design, the machines are basically the same, especially if we're talking about the same laser source that's internal to it. So a lot of times you're just kind of looking to see what is gonna be the cheapest price for you. So I find typically OhmTech is gonna be on the lower end in terms of price. So the 20-watt Galvo at $13.59 is a really, really good starting point. I would probably steer away from Atom Stack. That design isn't as robust as something like this. And I do know with OhmTech, you're using a Raycus laser source. That would be versus Max, which is gonna be on the low end. But also if you do want more power, there's actually a sweet spot that I'm finding in the pricing, and that would be getting into the 50-watt range. So the Monport GP50, which is what this machine looks like, this is just like the MOPA version of it, for $3,000. It's pretty good for 50 watts. But something I just came across yesterday, one that's gonna be a little bit cheaper, but it's also also a little bit older is going to be the Commarker B450. They actually have a B6, which is their updated design. And the big thing is it has like a little touch panel and it's got autofocus internal to it. But for my research, their like lower end wattages on the B6 is using the max laser source, which again is like the very budget end, versus their older B4 is using a Raycus laser source, so a nicer laser source. And because the overall product is older, a lot of times it's going to be cheaper. So you can see these are basically the same price, but you're getting more wattage with the 50. You just don't have quite as many bells and whistles, but you do have a more powerful and better laser source. So this one, if it stays that price, is a really good get. And then the Monport GP50 is a good one as well. Now switching over to the MOPA, again, you can see a lot of these basically look the same, but I'm going to recommend, even though I haven't tested this one out myself, I do like the stuff from Commarker here recently, especially their new B6 line. Once you get into the MOPA, because they are using that JPT laser source, so the higher end, and they have several different wattages within this line. But I like the 60 watts because if you're going to spend extra for the MOPA, and again, if you don't need like the color markings or some of the specialized stuff, I wouldn't even get one because they are going to cost more. But if you are going to go that direction, you definitely want to get enough wattage to power it. So I kind of like the 60 watt version even over the 30, but again, that price is about $1,000 more as well. But again, like I mentioned before, the B6 is pretty cool. You can actually remove the top portion from it and have it separate, so it can kind of turn into a split style design. It's got an electronic lift and it also has autofocus built into it. And it's got a little like color touchscreen panel as well. I hope to get one of these in to do like a full review on, but from what I've seen, it's a really cool pick. But definitely any of these other options would work as well. But if you don't need like all of those bells and whistles, you definitely can get cheaper options like the $4,000 from Ohm-Tech at 60 watts. All right, now let's flip it over to the Pro Galvo. Again, these are our split style design, even though like technically this guy from G-Wig I haven't put into that category just because it's a scaled down version. And we're gonna flip over to fiber. And for this one, I always steer people towards Cloud Ray because if you look at these, a lot of them basically look the same other than Thunder. And if you look for like a split laser, you more or less are getting the same machine from like the same manufacturer. They're just like rebranded for our different companies. So Cloud Ray is always a really nice one to go with. So the QS30 from Cloud Ray at $2,600 would be my recommendation for folks wanting to go that direction. And again, switching over to MOPA, it's pretty much the same as like the traditional Q-switched fiber, where basically these machines are the same thing. The only thing that is changing is the name on the box. The actual laser source is pretty much going to be the same. And so you're just really looking at wattages and like colors. So really price is kind of like the key factor that's going to differentiate them. And recently, Commarker is coming out with the Titan 1. And as of right now, they have a 60 watt version that is a MOPA for $5,000, which if we're looking across is definitely on the low end for price. So the Ohm-Tech 60 watt is $5,800, Cloud Ray's is $6,600, and then EMP, which is also like Aeon, or like Aeon's like a sub brand of them, is like over $12,000 for 100 watts. But this Titan, you can also get 100 and a 200 watt version. 200 watts is definitely pushing it. It's like $5,000 for 60, 7,000 for 100, and then 9,000 for 200 watts. So you can get a lot of power, still less than $10,000 for a MOPA. Again, this is a brand new product. I want to test it out, but this is a really interesting price point if you want to get it. And last but not least, let's talk about that machine right there, the xTool F1 Ultra. I actually currently have it as one of my top picks. And it is a 20 watt traditional fiber laser. So it's not a MOPA, and I believe it is a Raycus source, but it also has a 20 watt diode laser in it as well. So they're basically taking like a 20 watt module from the xTool S1 and then integrating it into the F1 Ultra. So really you can mark on all different types of materials. But if we're just treating this as like a fiber machine, again, going back to the Ohm-Tech 20 watt, that's $1,300 versus the F1 have to come all the way down to $3,700. So that puts you in like the same price category as a lot of like 50 watt machines and even some lower end wattage MOPA machines. machines. I don't recommend the F1 Ultra because of the sheer specs. I really recommend the F1 Ultra because of the entire package. It pretty much has all of the bells and whistles that any of these machines can have. It's got autofocus built in, it's got a camera, it's got a mechanical lift that goes up and down. It actually has its own touchscreen pad it can interact with. But regardless of even all of that, why I do wind up recommending xTool to lots of people is because of their software. Their software has come a really long way, and in terms of the ease of use compared to something like Lightburn, it's much easier, and in terms of capabilities, they're getting a lot closer to each other. And since they can tie into the cameras, they can do like auto positioning. It's got this crazy conveyor belt accessory that you can add on to it as well. It's just a really cool machine. But if you're looking for like straight specs and you're looking for a nice quality laser source with high power, you definitely can get something more powerful for less money. You just don't have the entire xTool package wrapped around. Now, a lot of these companies will have different deals and promos. I have those listed on my site as well, machines for makers. If you have questions about fiber machines in general or a specific one, I would love to know down in the comments. I'll do my best to answer. All right, until next time, go make or break something in your shop. See you guys.